Hey guys, we're working with systems of equations, and we've also been using the new thing with equations where there's no solutions or infinite solutions. So today, our lesson is systems with no solution, okay? And then also there's systems with infinite solutions. We'll get to that. You'll see it in the substitution method, the elimination method, and also on the graphing. And so we're going to look at those, and then we'll come right back around and do the infinite solutions. For substitution method, we find a letter all by itself. Then we sit here and we're like, hey, what's it equal to? And then, you come up and this letter that you find here, you find it in the other equation. And then what this letter is equal to, you pop it in and you substitute it into that letter. We know that. And so this became x plus 2, and then we've still got the x minus 1. And now we're all set up ready to solve. This is just our normal equation solving skills. But when we decide to get all the variables to one side, by subtracting 1x, when we do it to the other side, right here, we find out that it cancels x's on both sides of the equation. So what's that leave us? 2 on the left and negative 1 on the right. And so as a result, we have no variables left over, and 2 does not equal negative 1. It says it does, but it's a false statement, so we know that this is a no solution. So you treat the substitution method the same way every single time. You go and you solve the equation that you have after you've substituted this in. But if you see that variables disappeared on both sides, then you go back to your skills of reading whether it's an infinite solution or no solution. And it's going to happen the same way over here with the elimination method over as well. So let's go see what happens with this elimination method. Initially, it does not look any different, but we go ahead and we add our x's together. It helps a lot if you just understand that those are ones in front of the x's, and if you can see them, great. If you don't need them, great, but it helps most people, so I'll put them in. This is fine. You've seen it where the x's cancel. Negative 1x plus 1x cancels. That's okay. But it's when you find out that your y's also cancel. That's when people go, whoa, what's going on here? And this is one of the few times where we're left with these being canceled where we need to put something down here. Here's the problem. If I put my pen right there, you can see that there's nothing left on the left side of that equation. There's nothing. What number represents absolute nothing? 0. And then we can go ahead and add negative 1 plus 4 is positive 3. So we have no variables left over at all. And this is also a false statement, so that would be no solution. So we've handled the substitution method for no solution. We've handled the elimination method for no solution. It's very similar. When the variables go away and you have a fake statement, it's no solution. You're used to that. But what about the graphing? Let's graph these two equations on this graph right here, and let's see what a no solution looks like when we graph them. So, our y-intercept's negative 1, our slope is positive 1, so it's up 1 and over, and we just put all these dots right there because we don't know where the second line's going to touch. That's how we do the graphing method. Where the two lines touch, it's a solution. So let's go graph this one right here. Starting number is 2, or a y-intercept is what we would call it. But we have the exact same step number. It'd be a positive 1 right here. And it starts to become very clear that these two lines are never going to touch. Even if I run this line all the way back down through here, we have perfectly parallel lines, which that makes sense because when you have the exact same slope number, the same step number, the two lines will not touch, okay? And so as a result, we would say that it is a no solution. So that's the no solutions. Now let's take a look at infinite solutions for all three methods as well. Again, I just have to clarify that it looks normal for elimination method and substitution method, but once you get into it, then you start to see something's a little different. The x is canceled out here, and what's left over is a true statement without the variables, right? So 1 does indeed equal 1. That's why we call it an infinite solution. The same thing is going to play out right here. Most of the time this is camouflaged and you have to multiply one of the equations or both of the equations to get them to set up. I've already got these set up to where we can just go and add them, and you're going to see what's going to happen. The x's cancel, and the y's, they cancel too. And in this situation, again, since nothing is left to fall down to represent the left side of the equation, we've got to show something that represents nothing, so we're going to put a 0 on the left side. And 0 plus 0 is also 0. And this is a true statement. There's no variables there. So in the same way that we saw it before, we'd have to say this is an infinite solution situation. Let's go take a look at the graphing setup for infinite solutions. Well, here we have the first equation that we can easily graph, and this one is probably going to cause you some questions, so we'll handle this in just a second together, okay? So let's go graph the first one. Start number's 1, that's our y-intercept. Our step number, or our slope, is 2. I'll leave the arrow off this in case I need to extend this down, but let's go and graph this one. How do we do it? Well, for the second equation, you'll need to rearrange it. You like it when the y is all by itself, and then normally we have something with an x, and then you have your y-intercept number back there, the plus or the minus number behind it without the x. So here's my question. How can I get that y by itself? Obviously, we have to get rid of this. Well, you know how to get rid of this. Remember how we talked about how we move variables to one side of the equation? In this case, it's negative 2x. So we would say and that gets rid of it for us. There's no problem with that. But the y is able to drop down, and that's what we want by itself. But what do we do with this side? This 1 doesn't have an x. So you've got two options. Some people line it right up underneath the 1, but remember, we can't add these two together. It's not going to become 3x. It's not going to become 3. This has an x, that doesn't. Okay, so get that out of your head. But one option is that you can write it where y equals and have the 1 fall straight down and put the 2x just off to the side. That's perfectly legit. However, it looks a little funny because we're used to the x term first. So another way to do it is just decide to write the 2x first and then let that positive 1 sit over here behind it. And since it's positive, make a plus sign. This is the exact same thing, right? So you've got to make that choice right here. Do you want the 1 to fall straight down and the plus 2x behind it, or do you want the positive 2x to fall right here and the 1 fall down behind it? I recommend dropping the 2x first because that's what you're used to seeing. That's our slope number. That's our step number, right? So I recommend just dropping that down first and having the 1 fall behind it. Well, compare this with that. What's your y-intercept number? Well, it's 1. What's your slope? Well, it's 2, and that means you're going to go up 2 and to the right 1. So watch this. Up 2, right 1. Up 2, right 1. It's the exact same line. Every single point's going to match up. It's the exact same line. So we don't have just one line here. We actually have two lines. We have one line underneath it, and the second line is laying right on top. In fact, I'm going to come through and put black right over the red. But you can still see just a little bit of red there. I'm hoping you get the idea that there are actually two lines here, and they're touching everywhere. They're touching in more than one spot. They're touching in infinite spots. So there's infinite possible solutions to the system. And you normally don't see this because they try to camouflage the second equation so it doesn't look like the first. But once you untangle it to go graph it, it's the same thing. So if you ever see one line and they're saying it's a system, know that it's actually more than one line, and that would be infinite solutions.